Welcome to Data Science 1, Probability, Bernoulli Experiments. Okay, so far we've been talking about counting rules. We have the multiplication rule, permutations of a subset, combinations, and so on. Now, here we're going to take a little bit of a diversion in the sense that we want to start thinking about experiments in and of themselves and how they can be looked at. So here we're going to start with the simplest experiment. The simplest experiment is the Bernoulli experiment. It's one where there are exactly two outcomes in the sample space. So we've already seen one of these, which is goal, no goal, right? When we were interested in soccer or football, in America. So anyway, here's a few more. On or off, alive or dead, pregnant, not pregnant, success, failure. Notice that there are only two possible outcomes and there is no in between on any of the states. So you're either one or the other, nowhere in between. Okay, so with a Bernoulli random variable, this is the first time we've talked about a random variable. A random variable is the way we take the outcome we see in the sample space and turn it into a number. So here, the random variable is typically x is equal to 1 if we observe the event and 0 otherwise. So this formulation allows for us easy calculations later. For example, on and off is our sample space. Here, if we let the random variable be equal to 1 if it's on and 0 otherwise. Another one, success and failure. Here, we're going to let x equal 1 if it's a success and 0 otherwise. Very, very simple, and it turns out that it makes our calculations easier later. Okay, if we want to turn Bernoulli experiments into probabilities, we can make use of the idea of what's called a probability distribution, and we're going to denote it f, which is a function that assigns probabilities to each value of the random variable. Tells us how likely each value is. So f of x, this little f of x, is equal to the probability that capital X, our random variable, is equal to an observed value. Little x is what's been observed, or could be observed. Okay, this isn't easy for a Bernoulli random variable. Here we have f of x, and that's the probability that x equals little x, which is equal to the probability p if x equals 1, 1 minus p if x equals 0. Since here p is the probability of x equals 1, which is the probability of success on or whatever outcome's been assigned to it, then we have the complement of that is it being off or failure or whatever the alternative is for our complement. So it would be 1 minus p. And here we can show that since we know they add up to 1, then f of 0 must be 1 minus p. All right, so Bernoulli experiments are really, really simple, and we'll look at more of them later. And they form a lot of the bases for more complicated types of experiments. Turns out that this thing is really, really useful. The random variable is really easy to define. What we mean by random variable is how do we assign a number to our outcome? It's going to be 0 and 1. Probability distribution is easy to understand because it only requires probability of one of the two possible outcomes. And notice, we didn't need any counting schemes in this. But as we go forward, we will need those. All right, so let's go look at some more experiments and random variables in the next video.